So it is the last thing to ever happen in the universe.
The universe today is happy and healthy, with exciting things going on. But at some point, the night will turn dark. Everything that once was will peacefully sleep forever.
Huh.
But what is
Yes.
the last thing that will ever happen, and when will it be? It turns out there is such a thing, and you probably haven't heard about it. Let's travel to the end of the universe
Which is about gamma radiation.
and look at the last thing. After a messy birth, our universe was a sleepy baby, warm and dark, filled with swirling clouds of hot hydrogen and helium. The story of creation is a story of this gas and where it will end up. Shortly after, the universe got busy making the first generation of stars. They were massive and lived violent lives, forging new elements, only to release most of them when they blew up. Countless stars were born and refined the gas available in the universe, cycling matter around, each generation giving most of its gas and fresh elements to the next. But not all gas is returned. Every time a new generation of stars forms, they also make more and more red dwarfs that burn slowly and live for trillions of years. When they die, they don't give their gas back to the universe, but turn
this
into
is-
white dwarfs.
Yeah,
So
the white dwarf. I think about this one.
red dwarfs lock up more gas forever. Some more gas is locked forever in other remains of dead stars, neutron stars
And they all exploded in the ending or something.
and black holes, which is bad as it reduces the material available for new stars. Today, the universe is a great home for us and will remain so for billions of years. But most of the gas has been used up or trapped. Over 90% of the stars that will ever be born have been born already. To get to the last thing to ever happen, all other things need to happen first. The next few hundred
Can I
billion
use
years will
Ember?
be fun and a great time for galactic exploration. But step by step, large stars and stars like our Sun will die out. Eventually, almost all the stars will be red dwarfs slowly dying. The end of everything, but not quite. In a few trillion years, the cosmic gas will finally have run out. About 88% of the mass of every galaxy will be white dwarfs, 2% neutron stars and black holes, and about 10% gas giants and sad brown dwarf losers. White dwarfs are the corpses of old stars, not much bigger than Earth, but on average as massive as half our Sun, some even much more. This makes
I
them
didn't know they had that much weight.
the third densest objects in the universe, after neutron stars and black holes. About 1 million times denser than the Sun today. Since they used to be active stars, their surface can be as hot as 150,000 degrees. White dwarfs are dim, hot, dense spheres that don't do anything anymore. But eventually, even white dwarfs will die because they're slowly losing their heat. It takes at least 10 trillion years, more than 700 times longer than the current age of the universe. As they do their cooling down, the universe around them will irreversibly
10 trillion years. Okay, I don't think a human being can imagine that.
grow dark as more and more white dwarfs burn out and turn into dead husks, black dwarfs. Spheres of death, as cold as space itself, invisible against the dark backdrop. Over trillions and trillions of years, every object in every galaxy is eventually either ejected into the void or its orbit decays and it will fall into the central black hole and be destroyed. In about a quintillion years, all galaxies have evaporated and every object is on its own, in the center of its own observable universe, emptiness as far as can be seen in any direction, traveling through black nothingness. Still, there are things that will happen.
Yeah, it is still hypothetical, right?
Black holes are dying, slowly. They'll fizzle away by emitting Hawking radiation until they're so small that they die in a final flash of light. This will take about a googol years, 10 to the power of 100 years, until the last supermassive black hole dies. A number so absurd, there's nothing to
Yeah.
compare it to. Maybe some living beings could have survived around black holes, but even this science fiction option ends now. After this unsettling amount of time, we're not even close to the end. Now is the time of the black dwarfs. It turns out there's some weird physics going on inside the dead husk of stars. The weird physics of black dwarfs. A black dwarf is a sphere the size of Earth, as massive as a star, but almost as cold as absolute zero. Stars stay alive because of their intense heat in their cores. So why do black dwarfs not collapse into a black hole? What keeps them together? Deep inside a black dwarf, matter is squeezed to densities millions of times greater than anything we see on Earth. The pressure is so great that electrons can't combine with the nuclei to form atoms. Instead, matter is weird, degenerate. The nuclei are compressed by the weight of the star, locked into a rigid lattice, while the electrons form a plasma between them. And these electrons hold the star together. We're simplifying, but imagine matter as a subway train and electrons as passengers. If there are empty seats, passengers spread out because they care a lot about their personal space. But as a black dwarf is so incredibly dense, this is like squishing more and more passengers into our train. Gravity is pushing in, trying to collapse it. The passengers are forced to sit and stand close together, which they hate.
No.
And so the passengers, our electrons, try to push out against gravity as hard as they can. This way, the electrons that are having a horrible time in the crowded train that's the black dwarf hold up the star. Everything else in the universe may have crumbled already, but these tiny particles push against each other until the end of time. Or they would, if quantum mechanics didn't ruin everything. Simplifying a lot, when particles get close enough, sometimes they can jump at each other and fuse together, a process called quantum tunneling. This happens constantly in stars because of their intense heat. It's one of the key reasons stars can fuse elements into new ones. But it also happens at a temperature near absolute zero, just, well, mind-numbingly slowly. This is the final step to creating the last interesting thing to ever happen in our universe. Here, in this lone black dwarf, something fantastic occurs. Nothing happens for 1 trillion years. Nothing at all. Can you imagine that? But then, a single fusion reaction. 2 carbon nuclei combine by quantum tunneling to become magnesium. Another 100 trillion years pass. It happens again. Then nothing for another bazillion years. Oh, 2 oxygen nuclei combine into silicon.
Yeah, I don't think no one's waiting that long.
As eons pass, the nuclei in the frozen black dwarf slowly combine, making new, heavier nuclei. And these take even longer to fuse, but given enough time, they eventually will. Remember the breathtaking amount of time it took for a supermassive black hole to evaporate? That's a brief moment in comparison to what's going on here. The difference between a second and trillions of years has lost all meaning. Over a time so absurd that it has no name, nuclei keep fusing into heavier elements. Until, when silicon nuclei fuse, they form nickel-56. Nickel-56 is radioactive, which means it's unstable. And when it eventually decays and turns into iron, it emits 2 positrons, antimatter electrons. And these 2 positrons find 2 electrons and annihilate them and themselves. Which is a problem. Remember how the uncomfortable electrons produce the pressure to hold the star together? Destroying the electron means fewer friends to help them hold up the star. Losing an electron does not give them more space to scratch their butts, it just makes gravity squeeze harder, the walls closing in on those that remain. In the case of the most massive black dwarfs, this is catastrophic. Bit by bit, the black dwarf turns into a sphere of iron and more electrons are annihilated. For at least 10 to the power of 1,000 years, almost, but not quite forever, there's no visible change in the entire universe. And then, finally, the last thing to ever happen
What happened?
happens.
It exploded or
The
something?
dwarf has lost 1 too many electrons. It can no longer support its immense mass and goes into an uncontrolled collapse, a supernova.
Yeah,
It
there you go.
first implodes and then explodes as bright as a galaxy and fills the empty universe with light again. A beautiful moment nobody will get to enjoy. And then, as quickly as it began, it's all over. Darkness again. Emptiness.
Yes, aware.
That was the last thing that will ever happen.
A supernova
The
at the end.
universe may now be truly dead. But don't be bummed out about it. This is so far away in the future that forever hardly describes it. Today, the universe is the best place it could be for us. And you can sleep tight tonight, knowing
thanks,
the last
man.
interesting thing that will ever happen is forever long away.
Okay, guess that will be the ending there. Otherwise, yeah, that was an interesting video, I guess. That was the ending of the video right there.